Hi students, welcome back. So we have another interesting and real-time project called water level monitoring system. So here we are going to keep an eye on the level of water in the overhead tank at our home or in the institute or any place. So there is an ultrasonic sensor that we place, and the level of water in the tank is at a distance from our sensor. If the level will fall down, that means there is less water in the tank, then we say, okay, now it has gone below certain limit, the motor should be on, the pump should be switched on. And when we have started the pump, it will start filling it, and if it goes beyond certain limit, then we should say, okay, now we can switch off the pump. And if we want to know what is the level of my water in between, there should be some indicator in form of an LED array which can tell us on a scale of 1 to 5 or 1 to 10 how much water is there in the tank. So now we have the objective clear. Let us look at the components that we need. We need the Arduino Uno, ultrasonic sensor which is going to tell us what is the distance of water level from the top of the tank or where the sensor is mounted. We need resistors, LEDs, buzzer, relay and motors. In actual implementation, instead of DC motor, it will be an AC pump and relay will be used. If you are just doing it for demo purpose, relay is optional. You can directly trigger the DC pump. Okay, so let us look at the circuit and how does it work. So here we have first of all our ultrasonic sensor. It will be mounted on top of the tank and it will be looking downward so that the sound waves are reflected from the water surface. Then we have this LED array which is in a vertical way. Here it is horizontal, but it will be mounted in a vertical way, or you can have it in horizontal way also. It will tell you that on a scale of 1 to 5 you can have more LEDs also. On a scale of 1 to 10, how much is the water level in my tank right now. We have a buzzer to sound the alarm that now the tank is filled, and relay with a DC motor for the water pump activation. Now we are going to check the circuit simulation on Tinkercad along with the code. So we have the circuit ready. As you can see, we have connected 5 LEDs on 5 digital pins. We are taking our ultrasonic sensor inputs from pin number 11 and 12. Buzzer is being controlled by pin number 5, and here the same pin number 5, if you see here, one is going to the buzzer and one is going to the relay here. So from downward this wire is going to the relay. That means our pump and buzzer, they will be activated at the same time. They may be activated in the opposite logic, that is a different story. Once the connections are fine, we are going to have a look at the code now. So here I have my trigger and echo pin at pin number 11 and 12. I declare a variable of type long with the name distance and integer with the name duration. I have these pins 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. These are my output. 12 is output, 11 is input. This is our setup function. No complication, very simple. Now coming to the loop function. See, what are we saying here? First of all, digital write 12 as high, digital write 12 as low. Duration is pulse in echo high, and distance will be 0.034 divided by 2, that means 0.017 multiplied by duration. If you remember, when we discussed about ultrasonic sensor in the previous videos, we had used a 3-pin sensor. Here we have a 4-pin sensor where trigger and echo are different. So what are we doing here? Look, pin number 12 is connected to trigger. So from trigger I am sending high and low signal at a duration. So I will be receiving them at echo. Once I receive that, I get the value of duration, and duration multiplied by this factor, this is the same number 0.017 which we discussed in that video. When we multiply with that, we get the distance, right? So what is this number? Basically 0.034, 330 meter per second or 340 meter per second. There can be a slight variation, and divided by 2 because the sound wave is traveling double the distance. Once it is going to the water level and then coming back. So this is the reason for selecting this number. Now after I get the distance in centimeters, I say if the distance is less than 100, okay, or it is less than 75, less than 60, less than 45, less than 30, less than 15, depending on how many LEDs do you want and what is the actual level or the height of your tank, you can decide these numbers. I am assuming that 100 centimeter, that means around 1 meter, is the total height of my tank, and at 100 meter now I should start triggering something. Okay, so if it is less than 100 meter, I say digital write 7 as high. What is 7? 7 is this LED, that means first one. So if it is going to the next level now, which is 75, okay, at 75 I am saying 6 high. I am not saying anything about 7. Why should that not make any difference here? Because 75 is still less than 100, so I don't need to separately mention that 7 is also high. Okay, so if it is less than 100, 7 is high, otherwise low. If it is less than 75, I am concerned only about 6. 6 will be high or low. For the next distance, which is at 60 centimeter, I am saying the next LED, which is here, then the next LED, then the next LED. Okay, pin number 2, pin number 3 and pin number 4. So this is the simple logic. I decide the distances, and at every distance I will start glowing one LED at a time. Previous LEDs will remain on. That is the simple logic for the LED array. Now coming to the last, here I say if my distance is less than 15, now we are very close to the top. Then I say digital write 5 as high. 5 means the buzzer. So buzzer will start glowing. It will give you some sound here. And this pin number 5 is also going to the relay. Here I have made the opposite connection. Opposite connection in a way that motor is normally running. And when I trigger pin number 5, electromagnet is created, and you can see on the creation of electromagnet, the motor will get connected to ground. That means it will stop. So otherwise the motor is running, and when I trigger that now the distance is less than 15, then the motor will be off. So this is the logic. You can improve it. You can put the conditions like some reset buttons that or switch on switch off button, manual switch on switch off button for a motor. You can control it with and or logic also. All these possibilities are there for actual real world implementation. That thing you can explore. This is a simplistic implementation of this project. Now let us look at the simulation part. So here I start the simulation and I click on the sensor, and the distance right now is 109 centimeter, which is more than 100, so none of the LEDs are on. Here the motor is running, so that you can say is a bug in our program, because the motor is always running. I have not designed it to be controlled manually. You can add that functionality. Now I bring the distance down. As it is less than 100, the first LED is on. The motor is still working, it is filling more water. And I bring it down below 75, the second one is also on. I keep on filling it, and below 60 the third one is also on. Then the next level is at 45, so below 45 the next one is on, and after 30 the last one is on. So now I know that water is very close to the last level, and as I will bring it below 15, so you could see the buzzer was buzzing. It was giving an alarm that now it's time to switch off the motor, but the motor was automatically switched off. So now you can see that there can be improvements in this project. I want to give you some assignment. It will be given as the module assignment also, but you can start thinking of it right now. You have to make the change in such a way that when the water is filled up to the maximum level, the buzzer goes on only for a few seconds, and the pump will be off forever. So that means you have to separate these two signals, right? So I am sure you will be able to do that. So now we are going to have another interesting project in our next video, and that is burglar alarm. Keep learning. Thank you.